Hello, welcome to this video. Let me introduce you to the concept of mixtures under A-level chemistry. Now, this is just advanced level chemistry, but the basics are just the same. So I'll try to draw you back to what you've already done at O-level. And from there, that's where we're going to build up from. Now, we know that a mixture is a combination of two or more substances which can be physically separated, right? That's the definition that we know of a mixture. Now, types. We're going to look at the following types. The first one is homogeneous. Homogeneous what? Mixture. Now, a homogeneous mixture is also called a solution. Okay? So, this is a mixture. This is a mixture in which what? Substances mix what? Completely. Okay? These, they mix what? Completely. Alright? Without forming any layer of what? Separation. Now, any homogeneous mixture occurs in what we call, it occurs in a single phase. This occurs in a what? In a single phase. And that takes us to a definition of a phase being any part of the system that has properties, okay, and composition which is uniform. Is what? Uniform. E.g., let's say when you mix milk and water. When you mix milk and what? Water. These, they become in one phase. You can't tell which one is water, you can't tell which one is milk. Okay? So, that's what we need to know about a homogeneous mixture. Now, examples, they can be milk and water. Or what else can be a homogeneous mixture? Remember, we are saying it's a solution. Okay? Or when you get ink, mix ink with water. It's kind of, it will just be the same at the end of the day. Or when you get paint, that water paint, and get water again, you mix. It's kind of that at the end of the day, they are going to become one thing in a single phase. That's all about a homogeneous mixture. We move on to heterogeneous mixture. Heterogeneous mixture. Now, this is just the opposite of homogeneous mixture. Of course, we don't have to write in the exam and say it's just the opposite of homogeneous mixture. You fail. Okay. Now, this one, remember we said homogeneous, they only consist one phase. But heterogeneous, they consist of two phases. Are you together, right? So this is a mixture of two or more substances that do not mix. That do not mix completely. Hence, they show layers of what? Of separation. They show what? Layers of separation. Now, these, they occur in what? In two phases. For example, oil and water. When you mix cooking oil and water, you discover that there will be 2 layers, one for water and one for cooking oil. So for example, there will be one layer for water. Which one will be on top? Of course, water will be down, right? And oil will be on top here. So on top here there will be oil. So this is oil and this is water. So these are 2 phases because you can clearly see them. Okay, that means the properties of a heterogeneous mixture is not uniform, like we defined here, where we said they are what the properties and which are uniform. No, in a heterogeneous mixture they are not uniform. In fact, they are what? A non-uniform what? They have a non-uniform properties and composition, because each part of the mixture is going to have different properties and different what? Composition. Okay? So now that is about mixtures. Now, do you know the methods of separation of these mixtures? Of course, I won't talk much about this. I'll just list them so that you can have a clue. So let me just write method. These we've talked about them. You did them at O level, okay, for separation of what? Of mixtures. Number 1. These are the methods that you can separate those same mixtures that, for example, heterogeneous or homogeneous. You can use, the first one is decantation. Of course, decantation is a quick method of separating a mixture, the one with 2 phases, for example, oil and water or sand and water. This one is for hetero. The next one is filtration. Filtration is like decantation, but they are not the same actually. This one involves the pouring of a mixture on a filter paper. All right. Decantation does not involve pouring. It just involves, some of you have done this when you were young, where let's say there's water and sand they have mixed and you just want your water, where you let your water and the sand, you let the sand sit down there, then you just get maybe a cup, then you remove the water. That's decantation. You are letting the unwanted substance to settle down when you remove the wanted. But filtration, you don't have to wait. Whatever it is, just pour on the filter paper and you get what you want. This one is also for heterogeneous. Well, next is crystallization. Now, crystallization is important mainly for solutions, okay, where you have an impure solid which is added to an amount of a solvent, all right, which dissolves the solute. So it has to be a solution. So this one is for solutions. Now, this is a type of separation where the solution is evaporated to dryness, and what do you remain with? Crystals, and those crystals are the only wanted ones. So this is just for homogeneous. Next is chromatography, which we know. This one is our cousin. This one involves just identification whether a substance is pure or it contains some form of impurities. You can use chromatography to know whether something is pure or something is impure. And well, for this one, I say you can use a solution, all right, but you need a suitable solvent in order to help you identify whether that solution contains substances that are pure or not. All right, but we also have simple distillation. Simple distillation is for solutions as well. Now, this one is a situation where you put a solution in a round bottomed flask, you let it evaporate, you correct your water, then you collect the solids that remain in the round bottomed flask. Next is the fractional distillation, which separates mixture according to their fractions. Composition. So for example, if I mix water and alcohol and I need them, I need them as separate. Let's say I made the mistake of mixing alcohol and water, but I need the bag one as an individual. I'll use fraction distillation. This one is simple. Water and alcohol, they have different boiling points. So I'm going to insert a thermometer on the distillation so that the moment I know that this temperature has reached, I know that this liquid has evaporated. For example, water has a boiling point of 100 degrees when it's pure, right? Alcohol has got 78 degrees. So when I insert a thermometer there and this solution is boiling, the moment the thermometer reads 78, I know that all the alcohol has evaporated and it is being collected on the other side of the distillation. So whatever remains in the fraction, so in the flask, is water until it reads 100 there now. All right, ladies and gentlemen, I think I'll end here for today. I'll see you in the next video when you start looking at something else, something interesting. Look at the atomic structure.